Yo, what's up? I'm N1, and if you have somehow missed the latest speedrun drama, I'll catch you up on it. Recently, a video was released by Geosquare that implicated the popular Minecraft streamer Dream as a cheater at speedrunning, which as we all know is punishable by death. Now, Dream made a response video and had a PhD astrologist write a paper refuting the claims with a bulletproof defense. It wasn't really bulletproof, there was a whole bunch of holes in the response. As a speedrunner myself, I'm passionate about making sure those who cheat are brought to justice. I keep seeing people demean speedrunning by saying, it's just Minecraft. But what it really is a fun competition that some runners dedicate thousands upon thousands of hours to. So to cheat the people who have put in work regardless of it just being Minecraft is really low. So I thought Geosquare's video was pretty well done, but it was also overcomplicated, and I want to break down the statistics for the layman to understand, and perhaps change your mind if you think Dream is still innocent. This will cover Ender Pearl trades and Blaze Rod drop luck over the 6 streams the Dream was accused of, and I haven't seen the information itself refuted, so I'll be using the trades and drops from the paper in Geosquare's video. Let's get into it. Okay, so you guys might be thinking, N1, what makes you qualified to give this ultra statistical analysis? And I'll have you guys know that I have taken not one, but 2 university statistics courses. One was an intro course, and the other was specialized in geography, which I have a degree in. So if that doesn't qualify me, I just don't know what will. Once you guys see the math, you'll see that it's really simple stuff. It's just multiplication, division, a little bit of exponents. There is going to be a statistical equation involved, but it is fairly simple, and I will explain it to you guys. So let's get into the numbers. First off, we're looking at Ender Pearl trades. Now I'm going to treat these math explanations as if they were directed to a younger viewer, like Dreams, so don't feel like I'm patronizing you if you already have a good understanding of math. So just to explain Ender Pearl trades, each time you give a piglin a gold ingot, you have a chance to receive Ender Pearls. And what is that chance? It's around 4.7%. So if we were to do 262 trades, we would expect to get 12 Ender Pearls on average, where Dream here has gotten 42 on 262 trades. And we saw these numbers in Geosquare's video, and although accurate, I just think they're a terrible representation of fractions. Like, when is the last time you were dealing with 12 260seconds? So let's break these down a bit. Now if we look at the percentages, which you get by dividing the first number by the second and multiplying by 100, we can see that Dream got around 3.5 times better luck than the expected. Okay, pretty good. This can be further broken down into a 1 in 21.83 expected and a 1 in 6.24 for Dream. We can get these numbers by dividing 100 by the percentage, and this means for every 21.83 trades, on average you would get 1 Ender Pearl. But Dream, this mastermind, has cut that number to 6.24. Has this convinced you yet? I sure hope not, because this is not nearly enough information to make a conclusion. So now we're going to break down the odds in each stream. This is just simply the expected number per trades versus Dream's numbers that he got for trades. The Dream numbers are straightforward, but to get the expected number you divide the number of trades by the expected percentage in decimal form. So 69 divided by 0.0458 equals 3.2. As we can see, Dream outperforms the expected trades by more than 2.5 times each stream, which is quite the feat. Congratulations to Dream on that. Oh wait, you're telling me it's out of his control? Yeah right, Dream is just a god gamer. These are rookie numbers for Dream. Anyways, the thing that I'm about to show you next may shock you. That's right, baby, the binomial distribution formula. Now, it's not nearly as complicated as it may look, so for now, just ignore everything to the left of the equal sign. It just adds to the confusion. So ignore the p x equals r. I'll break down the variables for you. N equals number of tries, R equals number of successes, and P equals probability of success. Now we're ignoring the stuff to the left of the equal sign, right? So we have three elements in this formula. NCR, p to the power of r, and 1 minus p to the power of n minus r. I'll explain the most complicated first, which is the NCR. So this represents the number of possible combinations, and the C will be referred to as choose because this is how combinations are commonly expressed. In the context of Ender Pearl trades, N choose R represents all possible combinations of successes and failures. Now I can't really do this explanation justice, so just look up combinations on Khan Academy or some shit, I don't know. Next we have p to the power of r. This one is fairly simple, it's just the probability of success for the amount r, or in the context of Ender Pearl trades, r will be the amount of successful trades and p will be the probability of a successful trade. Finally, we have 1 minus p to the power of n minus r, which is the probability of failure for the amount of r, or the odds of an unsuccessful trade. N1, are you nuts? This is too much math. Why would you ever use a formula to solve your problems? Well, that's because it's applicable to the situation. So this formula can be used to get the probability of rolling exactly x same values equal to y out of a set. Or in the context of the speedrun, we can see the likelihood of having a successful trade, x same values, an amount of specific times equal to y out of the set, or the total number of trades. N1, you've lost me. Rolling? What the hell are you talking about? Well, I'm glad you asked. Let me explain what we're going to do. Do you remember the expected trade value of 1 in 21.83? You know what else has around a 1 in 21.83 chance? Rolling any single number on an icosahedron. I figured it would be easier to imagine the RNG with dice rolls instead of trades. This changes the expected value to 1 in 20 or 5%, which is increased in Dream's favor. So now imagine the expected value to be a flat 5% and we will be using that in our equation. Let's test out our equation on the expected value for the first stream. You may have noticed the equation has changed a little bit as there are now 2 funny hats inserted into the equation. Those just represent exponents for the ease of formatting. Now I didn't realize this, but you have to use full numbers for combinations, so instead of 3.2 we will use 4 as it is further away from 3.2 and will give us less likelihood than 3, just to further emphasize the odds. So we have 69 choose 4 times 1 divided by 20 to the power of 4 times 1 minus 1 divided by 20 to the power of 69 minus 4. 69 choose 4 becomes 864,501. 1 divided by 20 to the power of 4 becomes 0.0000625. 1 minus 1 divided by 20 to the power of 65 becomes 0.035647932. And when we multiply all these numbers together, we get 0.1926 or 19.26%, or a 1 in 5.2 chance. Not bad. So again, this is not Dream, this is just a number close to the expected value. Now we move on to Dream. From Dream's first stream, we have 69 choose 9 times 1 divided by 20 to the power of 9 times 1 minus 1 divided by 20 to the power of 69 minus 9. 69 choose 9 becomes 566,720,74888. 1 divided by 20 to the power of 9 becomes 0.000000001953125. 1 minus 1 divided by 20 to the power of 60 becomes 0.046069798. And when we multiply all these numbers together, we get 0.0051 or 0.51%, or a 1 in 196 chance. Okay, pretty lucky. Any speedrunner would be happy to get this kind of luck, and this is definitely reasonable, but let's take a look at the next stream. From Dream's second stream, we have 24 choose 8 times 1 divided by 20 to the power of 8 times 1 minus 1 divided by 20 to the power of 24 minus 8. 24 choose 8 becomes 735,471. 1 divided by 20 to the power of 8 becomes 0.00000000390,625. 1 minus 1 divided by 20 to the power of 16 becomes 0.4401266668. And when we multiply all these numbers together, we get 0.00013 or 0.0013%, or 1 in 76,923 chance. This is quite the luck. 1 in 196 followed by 1 in 76,923 chance. Man, Dream is good. Now, to be serious, this is highly improbable, but still possible. 1 in 100,000 chance events happening in speedruns are not unheard of. But when you get back-to-back runs of very good RNG followed by insane RNG, I don't know, this is definitely starting to get suspicious. That's enough math. I'm sure you're sick of it. Go take a shower to wash the nerd filth off and come back. I'll do the rest of the math for you. Alright, here are all of the odds of Pearl trades by Dream for each stream. And I think I may have accidentally cleared his name. If you look at stream 5 here, he got a 1 in 56 chance. How terrible for him. He could have done much better, like 1 in 76,923. For real though, stream 2 stands out like a sore thumb, so let's just ignore it for now. So for each of the streams, Dream got less than 2% odds. This alone would be very questionable luck. Now we add back in the second stream, and we have what we like to call in the biz, astronomical odds. Now I've already explained the math, so let's go through Blaze Rod drops. Just to explain Blaze Rod drop luck, on average it's a 50% chance of getting a Blaze Rod when you kill a Blaze. More than 10 times higher than Ender Pearl trades. And because of this, people seem to think it would be weird for Dream to alter his luck for Blaze Rod drops. But just wait until you see the numbers later. So here Dream did roughly 20% better than average. That's only 1 in 1.45 versus 1 in 2. This doesn't seem so bad. But let's look at the numbers once they've been run through the equation. The expected in this case is 50%, so I used that number instead of a theoretical die in Dream's favor when calculating these. Oh yeah, okay, a 1 in 14, that isn't statistically significant. Maybe Dream didn't cheat at Blaze Rod drops. Oh my god, 1 in 140,845 for the second stream. Okay, well I take it back. Here's the rest of the streams, and you'll notice that the 1 in 14 odds is the worst luck that Dream had in each of these 12 events. Well, that's inconclusive. There's no way that proves that Dream cheated.
Is this a dream? Or is this just fantasy? Just look at stream 2.
Again, let's ignore the big numbers here. Stream 2 and Blaze Rods in Stream 4. Even with all of these numbers, Dream may have been accused of cheating. It's a fine line, but this is simply unheard of. 9 events that got less than 10% luck, with more than half of the 9 events getting less than 1% luck. These numbers are still insane, and when we add the big numbers back in, there it goes. Out into space. Just astronomical. There is just no way these odds happen without a little cheating, or maybe a lot of cheating. Now my thoughts on this issue are simply this. Either Dream's game may be bugged, especially for Stream 2, giving him godlike RNG, or Dream actually got this lucky, but based off the numbers, it's basically an impossibility.
Or maybe I got the math wrong, but that's also basically an impossibility.
And Dream, if you did have a bug or actually managed to get this lucky, I am so sorry. Because the other option is that Dream cheated because he wants better speedruns, thus better content, and that Dream is a lying sack of shit.